This number under here is called the radicand. Uh-oh, I got something that must have graph paper under it. It's not wanting to write. Radicand. Looks like I've left something out, but I don't think I did. Radicand. And then this number right here is either the index or the root. And if there's no number there, which is what we're used to, it's square root. So unknown, without a number right here, this is going to be square root. Like the cube root of 8 is 2. See, I didn't put the little shelf there, but anyway. So that's an example of it, because 2 times 2 times 2 is 8. And obviously the square root of 16 is 4. We will talk about, we're just dealing right now with what's called principal square root. Like when we say the square root of 16 is 4. The square root of 16 can also be negative 4, and we'll deal with that when we get into equations. And let's do some simplify. Number 1, let's do the square root of 20. Now, do y'all remember your perfect squares? You know, is 20 a perfect square? Is we would do the factor tree of it, and we do the upside down birthday cake. You can do just a regular tree. It's, say 2 into 20, 10, 2 goes, there's your perfect square. 2 squared times 5. Break them apart, take the square root of this one, which is 2, square root of 4 is 2, and leave the 5 inside. Okay, let's do one more of those. Let's do the 4 square root of 60. Now, just to mention some things, this is your rational part. Now, they're all real numbers. You know, all of these are real numbers. They're on the number line. 2 is rational. I mean, you know where to find it on the number line. Square root of 5 is going to have to be an estimate, because when you punch it in your calculator, this is your irrational part. I mean, square root of 20 is going to be 4 point something. I think it's around 4.5, and then maybe 4, and then round up to 5. But you've got to realize they're irrational. The easiest I say is it's like pi. You know, pi is a number that never ends, never repeats. So when we talk about them in geometry and algebra 1, I call it the outside inside, but I want to call it more rational irrational in algebra 2, because that's what you want to be familiar with. And then, because we will address those when we get into quadratic equations. So in this case, I have rational, I have irrational. That is not a perfect square. We've got to break it down. If you do this factor tree of 60, remember, you're looking for its prime factors. So I always start with 2 and do 2's as long as I can. And then I go to 3's. So see, I've got 2 squared times. Now you can go ahead and put 15 there if you want to, or you can put the 3 times 5. I'm not doing it like I'm teaching it. I'm doing it like I'm reviewing it. Does it come back to y'all? We did a lot of it. So you got a 4 outside, a rational 4. You've got a square root of 4, which is rational. Just because a number's under is a radicand doesn't mean it. See, that's a rational number because it's 4. And then the 15 stays inside because the square root of 15 is irrational, and you end up with 8 square root of 15. Now, we break those down by perfect squares. Well, when you do them with variables, which we did not do in geometry, we didn't need variables in geometry. When you have perfect squares in variables, obviously x squared would be a perfect square, because what's its square root? What's the square root of 6 squared? 6. Do you have to know that squared? What's the square root of 18 squared? Do I have to know 18 squared? No, it's just going to be 18. The square root of x squared is x. Now the next one is, and we're not getting above that right now, but the square, well, actually, yes. But the square root of x, you really just have to know that one. The square root of x to the 4th is x squared. Because, now you have to be careful on that one, because x squared times x squared is x to the 4th, because you add their exponents. The square root of x to the 6th is x to the 3rd, because x to the 3rd times x to the 3rd is x to the 6th. Number 3, let's do the square root of x cubed. Let's break it down just like we did then. It's not a perfect square, but we can break it. Think about x cubed's perfect. Think of x cubed's factor tree. I don't have to do the birthday cake because it's just x times x times x. which is the square root of x squared times x. See, I'm grouping my perfect squares together. The square root of the x squared is x, and then this x stays inside. Now, on our classwork, it's going to say assume all variables are positive. But sometimes on the ACT, they don't say that. So to make them positive, you will see them do this. They may write it with absolute value bars. I don't use that notation because our worksheets don't do it. But just be aware that don't let that bother you if you see that on the ACT. Number 4, let's do the square root of 48m to the 5th. Now, I'm going to do it probably different than you would think I would do it. The factor tree of 48 is 16 times 3, so it's 2 squared times 2 squared times 3. I believe that's it. 4 times 4 times 3. Yeah, that's the factor tree of 48. And then m to the 5th. Now, you could do m to the 4th times m and take the square root of m to the 4th. You can also do it, a lot of people prefer just to write them in pairs, like we do this one. Instead of writing like 2 to the 4th power here, we separate them into pairs. It's your choice. I'm going to circle the perfect squares. That's the way I teach it in Algebra 1. And then I can take the square root of that 4, which is 2. I can take the square root of that 4, which is 2. The 3 is going to stay inside irrational. The square root of that m squared is m. The square root of that m squared, I'll put dots between everything, is m. And I'm left to 3m inside. So when I clean it up, I have, looks like 4m squared times the square root of 3m. Negative 5 times the square root of 45, a to the 3rd, b to the 4th. We'll leave the rational negative 5 out front. I'm going to break 45 into 3 squared times 5. 9 times 5, so the factor tree is 3 times 3 times 5. I'm going to break a cubed into a squared times a. Now, b to the 4th is a perfect square. You can either write it as b to the 4th, and its square root is going to be squared, or you can write it b squared times b squared. You write whichever you're comfortable with. So the negative 5 stays outside. The square root of that 9 is 3. That's rational. And we'll circle them. The square root of the a squared is a. That comes out. And the square root of whether you do it b squared, or do b to the 4th is b squared. And you have a 5a left inside. So I have negative 15 ab squared times the square root of 5a. So to add, subtract. Now the rule is pretty much what it is with variables. You know, if I have 5x plus 3x, I get 8x. If I have 2x plus 3y plus 5x, I get 7x plus 3y. You can't add them together unless they're like terms. What's the same thing? Like terms have same root. They have to be square root, cube root, and they have to have the same radicand. 8 squared is 6 minus 2 squared is 3 plus 4 squared is 6 plus the square root of 3. Like terms. 8 squared is 6 plus 4 squared is 6 is 12 square root of 6. Now be careful because a lot of people want to add those. Remember, 5x plus 3x, a lot of people want to put 8x squared. You know, are you multiplying or are you adding? Well, you're adding, so I have, you know, 8 square root of 6 is over here. I have 4 square root of 6 is over here. I have 12 square root of 6s. Now, if I have negative 2 square root of 3 and a positive 1 square root of 3, I have a negative 1 square root of 3 or just negative square root of 3.